Welcome to Designfusion YouTube video channel. In this video, we are going to see how you can do algorithmic model in NX. Here, you can right away launch algorithmic feature where in the logic editor, you can use different node and create a logic to create a customized feature for your purpose. In this case, I have bumper and in the middle face, I need to create a grill which has a hexagonal grid. The size vary from center to the boundary. Here you can see that I have already created feature where I have bigger hexagonal at the center, and as we go further near the boundary, the size is reducing. So I will right away edit and make changes to my input. Here I need 4 row and I will adjust my size scaling factor, and here I have the result of it. So let's edit algorithmic feature and see how I create a logic behind that. Here you can see that I have logic editor on the top, and on the bottom I have the preview of my result, and on the left side I have the nodes. You can use it to create a logic for your purpose. Here I have used a hexagonal cell. If you want to search any nodes, you can type here and search it. Here I have searched hexagonal grid and I got it. I have already used it. Here you can see that hexagonal cell looks like that, so I will not use that curve. I will only use the centroid of that each hexagonal for my purpose. And to create the hexagonal, I will use a polygon node where I call the sides as per my requirement, and also will define the radius using the logic. Here I have used that centroid and measure a distance from that center node. So I got distance for each centroid and use the maximum value, added it with the size varying factor, and then subtract those value from the maximum distance value, and take a square root of that to reduce that value further. And then to take control of the size of hexagonal, I have multiplied it with the size scaling factor and connect that port to the radius, so I can control my hexagonal size as I want and project that all the curve on the face. But here you can see that we have one half hexagonal which I don't want, so I have used the logic and tell that I don't want a curve which is 2 mm near to the boundary, and remove it. Here you can see that I have removed it from my result and use only the hexagonal which I required in my end result. Once it is done, you can also create a small version of this detailed logic using a snippet. So you can define a snippet for your purpose. In this case, project the hex grid on this face. So I have all. So you can save it, and you can also change the name of the input parameter as per your requirement, and that parameter you will see on your dialog box when you edit that feature. So I have already created one, so I will use it. So you can insert and use already created snippet. In this case, project hex grid. So I will delete that existing detail logic and will only use this narrow down version of this detail logic. So I will connect the project curve part as before. Once you connect it, you can right away right click on that project hex grid and create the input for it. So in this case, the main thing is I need to select the face. I select the face, and you can change the value of input as per your requirement. So I need 4 row along with I can say that to the software, and also would like to increase the size of hexagonal. So I will make my size scaling factor to 0.85. You can see what we are doing. We have the real-time preview of it on the graphic window. I need a smaller hexagonal near the boundary, so I can adjust it using a size varying factor, and here I have the result I want. You can finish and save if you want. Once it is done, you don't need to open a logic editor. You can do it right away by edit rollback and change the value as per your requirement, and here you can see that I have the result as per my input. This way, using algorithmic modeling, you can create a customized feature for your requirement, and this will make your modeling easy and faster than traditional method, and you can save it and also reuse it for other purpose as well. Thank you for watching this video. For more video, please like and subscribe our YouTube video channel.